All right, so let's see about this. Number one, a vector initial point, terminal point, find the component form and the magnitude. All right, so if you're going to do the component form, you have to subtract the end minus the beginning. All right, so we want 8 minus 3, and we want -2 minus 7 in our component form. All right, so that would be 5 and -9. So this is component form, and if somebody asks for it in standard form, that would be the I and the J. So we'll call this vector V, I guess, and it would be like 5I minus 9J. So, but this is what the question asks for, so this is the standard form. I'm sorry, the component form. Here is standard form. Okay, now we want the magnitude. So the magnitude of our vector, so we'll call it V. Those are the bars there, mean magnitude. You do the square root and you square each part and add it up. So we get basically 5 squared, so you get 25 plus 81. So that is the square root of 106. And you can leave it like that. All right, so for number 2, now if you did want to reduce radical 106, actually, so let's see, 106, let me try to divide it by 4. Nope. Well, I know it divides by 2. So that's 53 times 2. And so 53 is prime, so it doesn't reduce anymore. All right, so number 2, find the direction angle of this vector. So one thing to think about when you're starting off, -7I minus 2J. So -7 minus 2, so left 7, down 2. So it's going to be in the third quadrant. That's where that vector is. So we're going to start off, we do our tangent of our angle is the B value over the A value, so -2 over -7. So let's figure out the angle. So make sure your calculator's in degrees. Second tangent, I got -2 divided by -7, or just 2/7, and we get 15.9, all right? So remember, that's 15.9 degrees past 180. So to get the actual answer for the question, I would have to add 180 to this, and I would say 195.9. All right, so number 3. Number 3 says a vector, given those two vectors, find 1/2 u plus 4w. So basically, I want vector v, which is 1/2 of u, and u is 3I minus 2j plus 4w, so that's 9I plus 5j. So these things can be done with two-dimensional vectors or three-dimensional, either one. All right, so let's see. Half of 3, that's 1.5. Half of 2 is 1. And then 4 times 9, so 36I and 20j. So in the end, this is just like combining like terms. 1.5 plus 36, I got 37.5I. -1 plus 20, so positive 19j. All right, number 4. Vector has magnitude 8 and direction 120. Find the exact component form. So magnitude 8, so I take the magnitude and I multiply it by the cosine of the angle and the sine of the angle. Oops, sine of 120. So 120 degrees, that's double 60. So that's 120 is over here. So 60-degree angle has from the unit circle, I would have a 1/2 and a square root of 3 over 2, and I'm in the left and up, so negative here. So this is my cosine and my sine. So I got 8. My cosine is -1/2. My sine is radical 3 over 2. So if I multiply 8 by here, I get -4. And 8 times there, the 2 and the 8 make a 4, so 4 radical 3. So this would be the exact form of that vector, rather than like typing it in your calculator or something like that. All right, number 5, we got these forces, 500 pounds and 200 pounds, angles of 30 and -45. We want to find the direction and magnitude of the result of these two vectors. So basically, we got to add these two vectors together. So let's make them up. So let's see, I'm going to call the first one vector u, and it says that it has 500 pounds. We're going to do like we did before. So we got 500, and I have cosine of, let's see, 30, and sine of 30. And then vector v is going to be 200, but it's negative 45 degrees. So what's happening, we got 30 degrees this way, negative 45 degrees that way, and so I want to see like what's going to happen when somebody pulls on an item sitting here with those forces and at those angles. So cosine of negative 45 and sine of negative 45. All right, so basically what we have here is we have vector u is 500 cosine 30. So I got that number, and then I have my x part right here as well. So I have, I want to add to it, oh, I forgot the cosine. I was like, why is that so big? Sorry. 500 cosine 30. I thought it was weird. All right, so 433, and then I have 200 cosine negative 45. All right, that number. So I'm trying to add these together. These are the x components. So I'm going to take this one and add it with that one. Or I could have just typed in 500 cosine 30 plus 200 cosine negative 45. All right, so when I'm doing u plus v, I get 574.4. And then for the y value, let's see, I need 500 sine 30 plus 200 sine negative 45. All right, so I get 108.6. So it turns out that the vector is going right and up. So it's like right over here somewhere. That's my resultant. So I want the magnitude and the direction of this thing. So the magnitude would be the square root of both of those things squared and added together. So I will go ahead and do that. So I got the square root of 574.4 squared plus 108.6 squared. Okay. So the magnitude is 584.6, and let's see, this was in pounds, so pounds. So the result is that 584 pounds of force are going to be pulling you. Now we need to know in what direction. So for my direction, I need my angle. So tangent of my angle is b over a, so 108.6 over 574.4. And so to find the angle, and luckily it's in the first quadrant, so I don't have to fix it. So we'll just do inverse tangent. Okay, so my angle is 10.7 degrees. Okay, so that's that vector there. Okay, let's see, number 6. We want a unit vector. This is a 3D vector. We want to maintain the direction, but we want this only to be 1 unit long. So a unit vector means I need my own magnitude. So the magnitude of this vector here is the square root of, I got to square each part and add it up. So 16 plus 4 plus 25. So that says the square root of 45, I think. So 20, yep, 45. And so you can reduce that to 3 radical 5 if you want. You don't have to. But my unit vector is going to be 4 over radical 45i plus, I'm just taking the original vector and dividing it by this radical 45. So plus, then we got 2 over radical 45j minus 5 over radical 45k. Okay, or you could write it in component form. It doesn't really say, so you could write it like this: 4 over radical 45, 2 over radical 45, and negative 5 over radical 45. And this can be done with 2D or 3D vectors like this. All right, 7. Prove that these vectors are orthogonal or perpendicular. So that's going to be an easy thing. I'm just going to do the dot product. So I'm going to try to do v dot w, and it has to come out to 0. So to dot product 2 vectors, I got 5, 1, and 1, dotted with negative 1, 2, and 3. To dot them, I multiply each corresponding part and add it together. So 5 times -1 is -5, plus it's going to be 2, plus it's going to be 3. And it does in fact add to 0, so they are orthogonal. All right, number 8. Number 8, explain how you know if two vectors are parallel to one another. So they are parallel vectors are scalar multiples. So scalar means that you're just multiplying it by like a real number. Of each other. All right, so it says then give a parallel vector to 2, -5, 3. So if you had 2, -5, and 3, that would be parallel. There's lots of answers here. How about I multiply it by 5? I get 10, -25, and 15. Just pick something to multiply it by. Okay. All right. Number 9. So on number 9, I need a cross product and a dot product and an angle, so we need a new page. All right, so number 9, I have my 3 vectors here. So I like to have my vectors like in component form because I think that's a little bit easier. So my u is 3, 2, -5. My v is 2, 1, and 3. They don't have those pesky little letters in there. 5, -3, and 4. Okay, so part A says u cross v. Okay, so we set up our determinant. We have I, j, and k. If it says u first, then you got to write u first. So 3, 2, and -5. And v is 2, 1, and 3. So we are going to be getting rid of some things here. So my cross product, my first number is going to be the determinant of what's left when I cross off the first row and the first column and the first row. So see those numbers there? I get 6 minus -5. Well, 6 minus -5 is 11. So that's my first number. Now I cross off the middle. So these 4 numbers left, I get 9 minus -10. So that would be 19. But for the middle number, I make it opposite, so -19. And then the last one, I get 3 minus 4, so that's -1. Okay, so part B, u dot w. So 3, 2, -5, dotted with 5, -3, 4. So this is just a number. I'm going to get 15 plus -6 plus -20. So that is going to be -26 and 15. 11. -11. So a cross product gives you a vector, a dot product gives you a number. All right, letter C, find the angle between vectors u and w. So the formula for the angle is cosine theta equals, and it's u and w, so it's going to be u dot w over the magnitude of u times the magnitude of w. Well, luckily, I already have the dot product of u and w right here, don't I? Yes. Okay, so I'm going to use that. So it's -11. So now I need the magnitude of u. So it's going to be 9 plus 4 plus 25. So that's going to be 38. And then multiplied by the magnitude of w, which is going to be 25 plus 9 plus 16. So that's a square root of 50. All right, and I'm just going to go to my calculator and calculate that angle. So we need second cosine. I'm going to put my little fraction there. -11. Bottom square root of 38 times the square root of 50. Okay, so 104 degrees, 0.6, 104.6. All right, number 10. So in number 10, it says find the magnitude of the vector with that initial point and the terminal point, so I got to find the vector first, so I got to do the end minus beginning. So 4 minus 3 is -1. Nope, +1. 3 minus 0 is 3, and -5 minus 2 is -7. So the magnitude of this thing would be the square root of 1 squared plus 3 squared plus -7 squared. So that would be the square root of 59. All right, number 11. It says find the area of the triangle with these two vectors as two of its sides. So there's a formula that says the area of the triangle is 1/2 the magnitude of the cross product. All right, so we got to find the cross product. Then we have to do the magnitude of it and multiply it by half. All right, so let's do the cross product of these two things. So my cross product, sorry about that. My cross product is, where are they? -507. (1), -2, 3. Okay, so let's see. Cross off this one, I get 0 minus -14, so +14. Cross off the middle, I get -15 minus 7, so that's -22, but I'm supposed to make it the opposite. And then the last one, I get 10 minus nothing, so 10. So now I have to do the magnitude of this, so I need the square root of 14 squared plus 22 squared plus 10 squared. All right, those are too big for me. So 14 squared plus 22 squared plus 10 squared. All right, so that's the square root of 780. So you could leave it like that, or if you wanted to actually like get the square root, you can go ahead. So about 27.9 units squared, because it is the area of a triangle. Oh, but wait a minute, this is a parallelogram. So I have to divide it in half. So divide it in half to get, because I multiply by 1/2, right? To get a triangle. So let me divide it in half, and that gets me 13.96 units squared. So that should be my final answer, or this expression here. Okay, let's see, number 12. So it says here the coordinates of points L and R are here. O is the origin, so I'm going to find OL and OR. So if I'm going to find OL and OR, I got to do L minus O. Now O is the origin, that's 0, 0, 0. So if I do -325 minus 0, 0, 0, that's going to be -325. If I do 1, -64 minus 0, 0, 0, it's going to be 1, -64. So for part A, OL is -325, and OR is 1, -64. Okay. Now it says in part B, calculate the cross product. So IJK, -325, 1, -64. Okay, so cross this off. I got 8 minus -30. So 8 plus 30 would be 38. Cross off the middle, I get -12 minus 5, so it's -17, but I make it +17. And the last one, 18 minus 2 is 16. All right. Calculate the area of the parallelogram that has these as two of its sides. Okay, all right. I thought I forgot something. Okay, never mind. All right, so the area of the parallelogram would be the magnitude of the cross product, right? So the magnitude of this, I'm going to have 38 squared plus 17 squared plus 16 squared. So let's see about that. 38 squared plus 17 squared plus 16 squared. Okay, so the square root of 1989. So the square root of that is 44.6, we'll say, units squared. Okay, Let's see. So number 13 is a little bit of a challenge problem. It says, if you have these vectors here, find all values of lambda, that's what that symbol is, for which A is perpendicular to B. So I want these to be perpendicular to each other. So that means their dot product has to equal 0. So let's use that fact. So that means that when I do 2 lambda plus 3 and negative 4, when I dot that with lambda minus 2, lambda and 2 lambda, I should get 0. So it's like a little equation we're going to solve. All right, so let's see what happens. So 2 times lambda minus 2 plus lambda plus 3 times lambda plus, and I think I'm going to put a minus because it's minus 4 times 2 lambda. This has to equal 0. So let's see what we get. So 2 lambda, and you can change this to an x if you'd rather, minus 4 plus lambda squared plus 3 lambda minus 8 lambda has to equal 0. So I'm going to clean this up, lambda squared. So that's gone. These three things, that's 5 minus 8, so that's negative 3 lambda, then minus 4. So this I should factor. So lambda, what multiplies to negative 4 and makes negative 3? Well, that would be 4 and 1, negative 4 and positive 1, right? So negative 4 and positive 1, which means my answers are 4 and negative 1. So there we go. If lambda was 4 or negative 1, it would make this equal to 0, which would make my dot product equal to 0. So there you go. All right, and 14, that's just like a little conceptual problem. What's the geometric meaning of the cross product? So in other words, what does calculating the cross product of the two vectors produce? So I'll just use one of these examples. So remember that the cross product is a vector, and it produces a vector that is perpendicular to the original two vectors that made the cross product. So the cross product produces a vector that is perpendicular to both of the original two vectors. So if I did the dot product of like this vector and this one, watch what happens. If I do the dot product, negative 3 times 38 plus 2 times 17 plus 5 times 16. It should be 0. And if I did it with this one, 1 times 38 plus negative 6 times 17 plus 4 times 16, it's 0. Okay, so the cross product is perpendicular to each of the original vectors. And you use that a lot in upper level math stuff. Okay, that's it. We'll see you in class. Bye-bye.